Okay, a sample of propane gas. Propane is C3H8, 3 carbons, 8 hydrogens, having a volume of 2.70 liters at 25 degrees Celsius and 1.75 atm was mixed with O2 gas, mixed with oxygen gas, having a volume of 40.0 liters at 31 degrees Celsius and 1.25 atm. Okay, the mixture is ignited. Mixture is ignited to form CO2 gas plus H2O gas. Okay, question is, how much CO2 gas is formed at 2.6 atmospheres and 130 degrees Celsius, which is the conditions, pretty standard conditions for once you ignite something. So I have a sample of propane gas. It's sitting in 2.7 liters, temperature is 25 degrees Celsius, and the pressure on it is 1.75 atmospheres. That's in one vial. In another vial, I have 40 liters of gas, of oxygen gas. The temperature is 31 degrees Celsius, 1.25 atmospheres. I mix them together, okay? Mix them together and raise the pressure to 2.6 atmospheres, 130 degrees Celsius. I want to know how much CO2 is formed under these circumstances. Okay, well, this is chemistry. All chemical problems begin with an equation in general. A lot of kids end up just sort of starting to just jump into the math without thinking about what's going on. So let's go ahead and see what's happening. Well, we have propane gas. We're going to mix it, mix it with oxygen. We're going to do the balancing as we go because that's part of the process. We're going to create CO2 gas and we're going to create H2O. So let's go ahead and balance this equation first. I have 3 carbons. I want to put a 3 over here. I have 8 hydrogens, so I'm going to put a 4 over here. 4 oxygens, 6 oxygens is 10 oxygens, so I put a 5 over here. Now I'm balanced. 1 mole of 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide, 4 moles of water. Okay, well, given these gaseous conditions, I'm going to use the ideal gas law to find out the number of moles of each. This is a limiting reactant problem. I need to find out which is the limiting reactant in order to find out how much CO2 is going to form. So let's go ahead and get started. C3H8. Okay, the number of moles is equal to PV over RT. I've just rearranged the ideal gas law. I stick the values in here. I have 1.75. I'm going to skip the units. I hope you'll forgive me. 2.7 liters. Gas constant is 0.08206, and I'm at 25 degrees Celsius, which is 298 Kelvin. Number of moles is 0.193 moles of propane. Okay? Good. Now, let's see what else I have. I have to find out how much oxygen gas I have. Well, again, the number of moles is equal to the pressure times the volume over the gas constant times temperature. And now the oxygen is at 1.25 atmospheres. The volume is 40 liters. Actually, I said that I was going to skip the units, so let me be consistent here. Let me just leave the 40.0 there. And 0.08206 is the gas constant, and then I have 304 Kelvin because it's at 35 degrees. Yes, 30, what was the temperature of the oxygen? 31 degrees Celsius. Okay. we end up with 2 moles of O2. Now I need to find what the limiting reactant is. I take 0.193 moles of C3H8. The mole ratio is 5 moles of O2 per every 1 mole of C3H8. That means I need 0.965 moles of oxygen to react with the 0.193 moles that of the propane that I have. Do I have 0.965 moles of O2? Yes, I have 2 moles of O2. That means that C3H8 is limiting. It's going to run out first. Well, now I do the reaction. 0.193 moles of C3H8 times, now the mole ratio of mole of C3H8, the mole ratio of that and CO2, which is what I'm looking for, is 3 to 1. That's just straight out of the equation. And that means I produce 0.579 moles of CO2. Well, if I have that many moles of CO2, I go back to my ideal gas equation, PV equals nRT. Now, I'm looking for the volume that this is going to occupy. So, just the CO2, okay? Volume equals nRT over P. The number of moles that I've created is 0.579. R is 0.08206. My temperature now is 403 Kelvin. And my pressure is 2.60 atmospheres. I end up with 7.36 liters of CO2 gas. Now, mind you, what I've calculated here is the volume of CO2 gas produced, not the total volume of gas produced, because you know that water vapor is also produced, but I didn't ask about the water vapor. I used the ideal gas law to find the number of moles of reactants, limiting reactant problem. That's all this is. The ideal gas law is just a way, when you're dealing with solids and liquids, with solids you deal in molar mass. When you're dealing with liquids, you deal in molarity, moles per liter, concentration. When you're dealing with gases, you use the ideal gas law. You're still just dealing in moles. So these are just different techniques in order to handle the different states of matter, solid, liquid, and gas. Look at it that way. The same underlying principles are involved. We still want to know how much of something we're producing from how much of something we're given. That's all that's going on here. That's why we studied gases. Okay, so again, 7.36 liters of CO2 are produced. It says nothing about the oxygen. This is just the volume of CO2 if I were able to actually contain the CO2. Okay, so we talked about the gas laws, we talked about the ideal gas law, we talked about pressure, and we talked a little bit about the molar volume of a gas at standard temperature and pressure. So hopefully this gives you a little bit of a sense of the power of working with gases and working with the ideal gas equation in all of its various manifestations. Thank you for joining us here at Educator.com. We'll see you next time for the discussion of